successive reduction formulas in integration is to find an integral with respect to n in terms of in minus 1 or in minus 2 and so on. Something easier, something depending on a smaller value of n. This will be clear by some examples. There is an important example here is the integral of sine theta power n d theta from 0 to pi over 2. This is equal to n minus 1 over n minus 1. If you call the integral when the power is n, this integral when the power is n, we call it in. So when we write here in minus 2, we mean the same integral but replacing n by n minus 2. There is a condition here, n is bigger than or equal to 2. So the smallest we can get here is to put n equals 2, and this will give you I0. For example, if we need to calculate I4, therefore n equals 4, this is 3 over 4 times I2. We can repeat the use of this formula again. For this it is called successive reduction. So if we begin by 4, we lower it by 2, decrease it by 2, we get to I2. And then repeat the use of it again to find 3 over 4 times, use the same formula again and again and many times till we reach n equals 1 or n equals 0. I mean to get to I naught or I1, which is easy. Well, I1 is integral of sine theta, it's known. And the integral of sine theta to the 0, I0 is integral of 1 d theta, which is known to be 1 as theta as well, and the substitution will give you pi over 2. So do it slowly again. I2 will be, and now is 2, so it's 2 minus 1 gives you 1 over 2 times I number 0. N is 2, so we get I naught. And I naught is pi over 2. Why? Because I naught is integral 0 to pi over 2 sine theta power 0 d theta. This is 1, and the integral of 1 with respect to theta is theta. Theta from 0 to pi over 2 gives you pi over 2 minus 0, which is pi over 2. So every time we begin by an even number for this integral, we reach I naught at the end because we decrease the integral by 2 every step. We reach I naught, so we multiply by pi over 2. If we begin by I5, say I5, we apply the same formula again. The formula says n minus 1 over n. So it is 4 over 5 times I3. But what is I3? This is the successive reduction idea. The idea of successive reduction, we express I5 in terms of I3, and then I3 again, we use the same formula to get 4 over 5 times 2 over 3 times I1. The same again for I3, the same application again. Therefore, 4 over 5 times 2 over 3. But I1 is 1. Why I1 is 1? Why? I1 is 1. This is easy. I1 equal this integration when n is 1. Integration from 0 to pi over 2 sine theta power 1 d theta. Power 1 means nothing, but to write the thing without any powers, sine theta d theta. Integral of sine theta is known to be negative cosine theta, because derivative of cosine theta is negative sine theta. So we get this. Substitute with the upper bound to get negative cosine pi over 2 minus cosine 0. Therefore, cosine pi over 2, recall 1, 0, 0, 1. This is the cosine of pi over 2. This is the angle pi over 2. This is the cosine. So it's 0 plus cosine 0 is 1. Therefore, I1 is 1. And this is easy and known to everyone. So the idea is this formula will give you in integral sine theta power n d theta from 0 to pi over 2 will always be n minus 1 over n. Then n minus 3 over n minus 2. So we begin here by n in the denominator and n minus 1 here, and decrease every step by 2, negative 2, negative 2. And do it again until we reach 1 or 2. Until we reach 2 or 1 here and there. But we multiply at the end by pi over 2 if we begin with even number, multiply by pi over 2 if n is even, and multiply by 1 if n is odd number. The proof is as easy as well. It uses integration by parts. It's the same for cosine as well. So we prove one of them, the same. I give some examples about sine theta, so let's prove it for cosine theta. Proof of the formula for cosine theta to the n. The proof is very similar for the case sine theta. Let in equals integral from 0 to pi over 2, but be sure to have the conditions before you apply this formula, cosine theta to the n d theta. So you know the integration by parts formula, u dv equals uv minus integral v du. Or you can use the tabular form or di method as you are used to. So no problem, we will do it again. By the integration by parts, we divide it into two parts. Integration cosine theta power n minus 1 times cosine theta power 1 d theta from 0 to pi over 2. This is the u and this is the dv. But to put it in easier form, we put it like this. This is the d of sine theta. You know, d of sine theta, the derivative of sine theta is cosine theta d theta, so this is the same. But now we can use this formula. This stands for u, this stands for v. So applying this, uv means cosine theta to the n minus 1 times sine theta. This is part of the integral value, but we should be substituted by the bounds. Minus integral v du, v is sine theta, du means to make derivative of this one, which gives you n minus 1, the power down, decrease or lower it by 1 to get cosine theta power n minus 2 times the derivative of what's inside the brackets or the braces or the parentheses you have to get in between brackets again negative sine theta d theta. Easy substitution here, cosine pi over 2 gives this 0. So the multiplication will be 0. Minus substitution with 0 makes sine 0 is 0, so we have 0 in both substitutions. So we get rid of this whole bracket. So the situation is as you see now. So we can multiply and take this negative sign out and this n minus 1 out to get n minus 1 times integral. This is from 0 to pi over 2. Here we get cosine theta to the power of n minus 2 multiplied by sine theta times sine theta. This will give you sine squared theta d theta. Again, look at this. This will give you. This can be transformed into very similar thing, which is 1 minus cosine squared theta. So we distributed this term by these brackets. We get cosine theta to the n minus 2 minus cosine theta to the n, because we added the powers, and we have Now we have in equals n minus 1 times integral from 0 to pi over 2 cosine theta. Look carefully to find that this is the same original integral with power I minus 2 instead of n minus 2 instead of n. So we call this I n minus 2. And the other term will be n minus 1 integral from 0 to pi over 2 cosine theta to the n d theta. This is the original integral in. So we have simply algebraic relation connecting in, relating in with a previous one, which is in minus 2. n minus 1, in. Therefore, we can solve this algebraic equation to collect in plus n minus 1 in equals n minus 1 in minus 2. Simplification will give you in plus n in minus in equals this n minus 1 times in minus 2. Of course, this will cancel and we get the required relation. In equals n minus 1 over n times in minus 2. This is valid relation for this integral in bigger than or equal to 2. This is valid relation for the integral from 0 to pi over 2 of cosine as well as sine. This is the same, Jn, they are the same. This is sine theta power n d theta from 0 to pi over 2. This will facilitate our calculation of such integrals. Another important formula will be similar, but in the case of Kn integral of mixture of sine to the n of theta, cosine to the m of theta, d theta. Will be the same, but we have n minus 2. Here we begin with n plus m and subtract 2 as well, as previously mentioned, and so on till we reach 2 or 1. Here we begin as before with n minus 1, n minus 3, subtract 2 every step till you reach 2 or 1. The same for m minus 1 times m minus 3, subtract 2 every step till you get to 2 or 1. At the end, you multiply by pi over 2 if n and m are even, and 1 otherwise. That's it. You can do it yourself, but it's very easy application of integration by parts and successive reduction formula of integration. Thank you. بس خلاص.